Question 32. A cone and a cylinder are of equal volume. That means they have equal values for their volume. That's numeric values for their volume. So let's say the volume of the cone is 20 centimeters cube. Then the cylinder too is also 20 centimeters cube. The base radius of the cone is twice the radius of the cylinder. That means if the radius of the cylinder is r, then the radius of the cone is 2r. So if the radius of the cylinder is 3, the radius of the cone will be 3 times 2, that's 6. What's the ratio of the height of the cylinder to that of the cone? Now, two things are given to us here. We are given the volume, the radius, and we're asked to find the ratio of the height of the cylinder to that of the cone. You have to be very careful here. It says the ratio of the height of the cylinder to that of the cone. So you have to put the cylinder first before the cone. Look at option B and D of our options. So we have B as 4:3 and you have D as 3:4. That means if you put the wrong one first, you might get the wrong answer. So let's go on and solve. Now we know the volume of the cone. Since it says cylinder before the cone, so we'll put the cylinder as this and put the cone as C. So volume for a cylinder is V equals πr²h, and volume for a cone is V equals 1/3 πr²h. Second line says the base of the radius of the cone is twice the radius of the cylinder. That means if the radius of the cylinder is r, the radius of the cone is 2r. Now it says, what is the ratio of the height of the cylinder to the height of the cone? Now using this second line, that means we have to reinsert this into this, and our r here is r, so we can leave this as this. That's volume for the cylinder is πr²h, while for the cone it will be 1/3 pi. Now our r here is 2r since they have the same volume, so you replace this r squared with 2r. It's going to be 2r squared, so you have 2r all squared h equals v. Next is solve this to the next level. So we have on this side our cylinder is v equals πr²h, while on this side v equals 1/3 pi, and 2r² is 2 squared and r². 2 squared is 2 times 2, that's 4. Then r² is r times r, that's still r²h. Since they say we should find the ratio of the height of this to the height of this, that means we have to make the height the subject of the formula or the relation on both sides. Since we want to make the h the subject of the formula on this side, we divide both sides by πr² on this side. So πr² cancels πr², so our h equals v over πr². And on this side, first we can say this is over 1, then this is like all over 3, then we cross multiply. We have 3v equals π4r²h. On the next line, since we're looking for our h on this side, we divide both sides by π4r². π4r². This cancels this. On this side, we'll be left with h equals 3v over π4r². And on this side, we'll be left with h equals v over πr². Since the question says find the ratio of the height of the cylinder to that of the cone, that means you have to equate the heights to themselves. So you have on this side v over πr² ratio 3v over π4r². That means we've equated the two of them. Now the next thing to do is really pretty simple. All you have to do is look at these two denominators, lower numbers. This is the LCM of the two of them. By merely multiplying this π4r² by both sides, you get rid of the fraction. So let's do it. We have v by r² times π4r² ratio 3v over π4r² times π4r². π4r² cancels π4r². Now you have pi on this side cancels pi, r² cancels r² on this side. On the cylinder side, we are left with v times 4v, and on the other side we are left with 3v. Since we want the numerical ratio, that's numbers no volume, so we divide both sides by volume. So we divide this side by v and this side by v. So v cancels v here, v cancels v here. We have 4:3 as our answer. So we have a cylinder on this side and our cone on this side. Our answer is B.